Hello, everyone. I'm very happy to welcome Chad Larrabee today on our podcast for energy movement and for our YouTube channel of Non-Boring Pneumatics. Here we discuss various topics about compressed air, pneumatics, end users, air quality, and you can find here all world experts. And Chad, I'm very happy to talk with you today.
Great to be with you, Elvira. Thanks for inviting me.
Thank you so much for being here. I told you before, you're actually like the first person on the podcast who comes from the compressor industry itself. So we have people all around from the application, a little bit of the everything, some innovators in the pneumatic cylinders and the components, but a person who has so much experience on the compressors. I'm really honored to have you here today. Could you please tell us a little bit about yourself? What is your experience in the field?
Well, I started with Ingersoll Rand in the compressor industry right out of college. And I work for Ingersoll Rand today as a vice president for tendering, project management, and then product management. So I had about half of my career in consultative sales and sales leadership, and then I got into product management, and then eventually business leader as vice president. So that's my current role today, and enjoyed the compressed air industry and have worked in several other areas of compressed air, one being the Compressed Air and Gas Institute within the United States. So this is a consortium of manufacturers who are the united voice of the industry in the US and Canada. And I've held multiple positions. I've been a member of the system assessment section. I've been the chairman of the education committee, and also I'm a current board member of the Compressed Air and Gas Institute. I've also served with a organization called the International Society of Pharmaceutical Engineers, and this particular organization has all types of interests around pharmaceutical manufacturing and engineering. And I joined something called the Critical Utilities Community of Practice. And so this is the group of folks who are primarily concerned with pumps, chillers, water, processed gases, compressed air. So we put together a good practice guide several years ago, and we recently ISPE just recently updated to the newest version. So there is a good practice guide for processed gases out there for that industry. So it's been fun to kind of work in different areas of the industry and participate in different ways. And then currently, my current role in the ISO, or International Organization for Standardization, is to be the convener of Working Group 4 of the TC 118 SC6, Subcommittee 6. And this is for compressed air efficiency. And we have the ISO standard 11011, and I'm working with a team of folks to revise that standard at this point.
That's great. Just a little bit like off top that we met with Chad actually on one of the meetings, because I'm an expert in another group for pneumatic system. And we were really afraid that our standard, where we focus on the distribution line until the machine on the demand side, will go in the conflict with your side. And trust me, like for I think for 1 year, like okay, half a year, we've been working on our presentation and refining it, and like going into all to this discussions with the committee from Germany, from France, and then we had an amazing discussion with you. We just did the presentation, and you said, "Yeah, guys, they go ahead," and we were like, "Oh, they're going to block us! They're going to block us! We need to, we need to do something." I wanted to talk with you about this standardization thing.
Sure.
From my personal experience, I've been working there for it's 9th year actually, so now, and I feel like it's amazing thing that we do, and that the standard can help a lot of people, but it still takes a lot of time. So that the standardization, it's feels like life learning process, and at some moment maybe it will not be relevant when the standard will go out. I mean, what is your opinion about this?
Yeah, so I think this is the reason that ISO has a good process for updating standards because technology changes or something else changes in terms of practice that causes us or is the catalyst to actually make a change. And that's what we see today with the with Working Group 4 right now is on the ISO 11011. The general design is the traditional assessment where you would go and do measurement for some period of time, typically a week. It would also involve quite a bit of meeting with key stakeholders, and then at some point there's an output, and then there is a report, and then there's solution, right? That's defined. And what we find is, the instrumentation is changing. So, all of this measurement happens within 1 week or so, or some period of time. And it's this, it's the use of equipment or instrumentation for a period of time, and then it's removed and things are put back the way they were. So the question is, how do you maintain kind of day one health? How do you get instrumentation and data coming back, not just for 1 week or even a month or a few days, but how do you have it continually? And then how do you synthesize that information in a way that gives you, actionable results? So I think that's one way we see things changing in the world today with measurement anyway.
Mm. Do you also have this feeling that it's changing also because of the people that are using the standard? Because I think when the standard maybe was developed, there were mostly energy managers that would focus on the full facility, like full factory and the various utilities. And now we have more compressed air experts that use the standard, but sometimes like they feel, okay, maybe they need more details or they need more guidelines. What is your opinion on that?
Yeah, I think the more specialization you can have, the better off you'll be. Certainly the dynamic system of compressed air, there's a lot of knowledge that is required, both in terms of how equipment works and how it's used, right? We find most of the opportunity is not necessarily on the supply side, but usually in transmission and certainly the demand side. Good example would be there's an understanding that if you can reduce pressure, you should be able to save power. And on a positive displacement compressor, if you reduce the pressure, at the output of the compressor, then you should be able to save 0.5% for every PSI. That's a rule of thumb. Don't take me to the science on that, but that's a rule of thumb, right? Okay, great. So we take the pressure down on that positive displacement rotary screw compressor, and we get a resultant a reduction in power consumption. You also get by sending lower pressure, any of your artificial demand or leaks, or inappropriate uses of air, which might be open blowing. All of those things start to use less air as well at a lower pressure. So those are all great things, right? So now let's take it to a centrifugal system, and you say, hey, I'm going to reduce the operating pressure by, 10 psi, so I should save 5%, right? Well, it doesn't work the same with a dynamic compressor. So that's just one example of, hey, you have to know some things about the equipment, about how it's used, where you may be able to get benefits. So I think a compressor expert is going to be much better at rendering a solution than maybe the overall look at energy. So to answer your question, yeah, the more specific you can get, probably the better results you're going to have.
Yes. Talking about the low pressure, I'm always trying to find this connection between the use, like pneumatic component suppliers, for example, and compressor suppliers. We see now trend on the market of lowering
Yeah.
pressure for pneumatic components in the machine. There are some companies that did, like SMC, for example, they did now low pressure line of components. They reduce it until 4 bar. There are, of course, there are also many suggestions that use your cylinder not at 7, but like at 5 bar. In China, they have compressed air lines for 3 bar, like low pressure, and then they put like the pressure boosters for that. What do you think, does it make sense? Is it like very application specific? Do you work also on the direction of the low pressure compressors? Because forgive me if I'm wrong, that they're more expensive, that they're going to be like piston compressors, right? And they're like more expensive for the low pressure, or what is the technology moving in what direction nowadays?
Oh, this is a great question. So usually it has to do with flow. Where are you in the flow range that is required for the compression, right?
Mm-hmm.
And just this is very, very simple, but somewhere in the 20 to 25 horsepower range, you move from maybe an air-cooled reciprocating compressor or maybe a scroll compressor into something like a rotary screw, and it can be an oil-free rotary screw or a oil-flooded rotary screw, right?
Mm-hmm.
And then once you hit somewhere around, let's say 400 or 500 horsepower or kilowatt, 300 to 400 kilowatt, you're probably going to be looking at only a centrifugal technology at that point. So
Mm-hmm.
and above, right? And certainly in my portfolios, we go up to about 20,000 kilowatts. So these are large process compressors. But it really does depend on the technology. Now, if you're thinking about the old double acting water cooled compressor that is reciprocating, those were very efficient actually, and they, because of maintenance costs and footprint costs, you had to do quite a bit from an installation standpoint. Building special bases and such. So those kind of gave way back in the 70s actually to the rotary screw compressor in that
Mm-hmm.
50 to 400 horsepower range. But they were kings of the market back then, and prior to the 70s. If someone needed in that fit somewhere, and I speak in terms of horsepower because I'm from the
Yeah,
US, but can
it's
convert
okay.
to
Yeah.
kilowatt
Mm-hmm.
pretty easy. Let's call it 37 to 300 kilowatt. But anyway, so you're in that range, and
Mm-hmm.
typically that would have been a reciprocating, double acting, water cooled reciprocating compressor. But we typically see those more in the higher pressure needs. So if you're bottle blowing, which is quite a popular industry now,
You mean
we're
like for 40 bar, like this high pressure
20,
application?
30, 40 bar. Water bottles have been,
Yeah.
now blown at now at about 22 bar, but certainly there's quite a few aseptic processes that are still at 40 bar. But yeah, you're in that range of 22 to 40 bar, exactly. So recips or reciprocating compressors have been pretty popular there. Something like a Bellis and Morcom 3-stage reciprocating compressor. It's double acting, water cooled, that kind of thing.
Okay. So
But
you
what we're
said that they
talking
were
about,
very,
or go
yeah,
ahead.
yeah, sorry. No, you said that they were like very efficient and they were very popular in 70s, but they became more specific just because of the price and the installation of the market. So
Yes,
what is
yeah,
the, yeah,
that was it. That was it. I call the rotary screw a set it and forget it design, right? It was so easy. You didn't have to, build a special foundation. You didn't have these unbalanced
yeah,
forces. So you could just put it on your factory floor and you were fine. You hit the button, it runs, it makes air. It really did change the market. It was a big paradigm shift in that, again, 37 to 300 kilowatt range. So that's really been the product of choice for what we would call plant air or instrument air pressure. And you were asking, well, what is that pressure, right? Because I'm only using 3 to 5 bar at the point of use. Why am I
mm-hmm,
making it at 7, 8, 9 bar, right?
mm-hmm,
And of course, this has to do with losses and people's need for some margin or safety factor, right? But it is true. We will find plants that say, I have to have, you name it, 8, 9 bar pressure at the compressor to get what I need in the plant. And then as we go in and make changes and realize, gosh, we can operate at a lower pressure. Well, there's a huge savings there. So that's always low hanging fruit, is can we operate at lower pressure or not? But most plant air pressure compressors are in that 7 to 9 bar range.
yes. Yeah, I have actually funny story. I work now on one project that the energy auditor asked me to do the calculation of the pressure drops because the client installed the pipes already, and the energy auditor says to him that you have a high pressure drops, so he needs 6 bar at the operation, and they proposed compressor of 9 bar. But they saw that the pipes are so small, so it's going to be such a huge pressure drop. So they proposed compressor of the 12 bar to have a
Oh,
6
wow.
bar at the to have a 6 bar at the end. And it was like such a big debate there. So they actually called a third party here to do the calculations, and it was indeed 4 bar. So just change the pipes. You can reduce your consumption here. So you can do the work on the demand side. But it's like anecdote of this week from my praxis. And yes, of course, you see that people feel uncomfortable if you lower the pressure, because this 6.3 bar, I call it like myth number that was created, comes from the 9-chip-C from the machine tooling, actually from the US. So yep. That just was adopted in Europe, that even now cylinder manufacturers write that 6.3 has to be the pressure at the actuator. That physically doesn't make any sense. But there are so many interesting myths around compressed air and pneumatics, and I really like that you mentioned
it's interesting, yeah, because you've had some experience like with those point of use products, right? Like
yes.
Festo. And compressor manufacturers, we for so long were always concerned about, well, what's happening at the discharge, or maybe through the cleanup equipment like the air treatment and the filtration and such. But certainly until we started looking at what we call article pressure, or the actual pressure that was used at that point of use, after all the many times red rubber hose, we called it, and fittings and drops and such. And it's kind of like, wow, it's so easy to just get so much, or remove the problem. Once we found the root cause was just all this pressure drop. So
exactly. Yeah, once you just opened the room from the compressor room and actually went out there, you just like see that there is so much potential to do so. I'm very curious in general about the trends of the technologies. I still have this thing in my mind that it was an efficient technology, and then just because it was hard to install, it was it's a little bit like forgotten. I mean, I understand, of course, maintenance cost and footprint cost. Where now stands in the terms of the development compressor industry in terms of all the sustainability, energy efficiency goals? What's happening there?
Yeah, it's interesting because you can look across whether all the markets, whether it be European or American, or even in China with certain GB codes. There is a definite movement toward more efficiency, and there is even regulation in some cases, right, where you might have to meet a certain efficiency standard. Typically, it's based on what's available in the market and you having to be within a certain band of what's available. And so we've seen that, of course, here in the U.S., which I'm most familiar with. We were moving toward a federal standard, and then that was held up, and then we've had some states move toward standards for efficiency. But all that to say, look, sustainability is top of mind for everyone, and efficiency, because 75% of the life cycle cost of a compressor is power. Your biggest win from a sustainability standpoint is efficiency. So manufacturers are always working toward having the most efficient product. Now, how you use the air many times is more important. And Elvira, you said it, it's out in the demand, it's out in the system, where you can actually get true savings. It's not just about making it for less, it's about using less. And so once we get out into the demand side, we find a lot more opportunities for savings than just maybe picking up a few points of efficiency on compressors. To your question, is there a new technology out there or coming for efficiency? We've seen some things, in this area, right? So within, say, like oil-free rotary screw design, typically that's a 2-stage compressor with a bull gear. And so there are losses associated with that bull gear. And so we've seen some manufacturers dual drive the air ends. In other words, put 2 motors on it, so you lose the losses. That picks up 3% roughly. you lose the losses due to the bull gear. Those are mechanical or frictional losses, right? And then if you variable speed it, you're able to match the compression ratios in each stage. And so that's an example of of a manufacturer doing something kind of different to try to, but still with rotary screw technology, to try to improve the efficiency. If your question is, hey, are reciprocating compressors the big old, reciprocating compressors coming back? I have not seen that at this point, other than for those high pressure purposes. Yeah.
Okay, great. It was really like a butter with honey on my soul when you started to talk about the first understand how you use it and reduce the usage of this.
Yeah.
So this is actually what I do, and then already you can do something with the compressor. I think it's more also on the control side, right? Like there are ways to use various compressors, like to take like one VSD compressor, like to compensate some peaks. It's this kind of technologies that already been
Yes.
on the market. If we talk about the system, overall system, you mentioned now the demand side, you mentioned distribution side. Do you work also with the machine suppliers, machine builders? Do you somehow try to cover it until the demand side? I mean, despite the fact that you work also on the standard that tells to check the demand side, or if not, like how you see in the future, how these two parts can be like putting together, and to make the maximum out of the compressed air usage, because it's such a robust technology. It's always been on the market, but there are so many various stakeholders that you need to have one who provides the component, one who provides the flow meter, another one provides the pipe, another one actually installs the pipe, and it's so easy to lose the track on this. Another one just is in compressor room. So there's auditor that can help you only with the compressor control, another one that goes and checks like the air quality. So what, in your opinion, like I know ideal world would look like in compressed air?
Well, that's a great question, because, we're even within the ISO standard committee, we're looking at, well, you have to think about the commercial aspects, right? Like what systems are worth putting all of that instrumentation on, the flow meters and everything. And if it's, 15 kilowatts, maybe you're going to do a walk around and an observation study, and you're going to say, hey, here's some inappropriate uses of air, or here's ways we can minimize leaks, things like that. And then we've kind of completed our work. But let's say you're now in a 1,000 kilowatt system. Your opportunities are much larger, right? And so you can do a little bit more involved studies and measurement. And again, to that point I was making earlier, how can I do this on a consistent basis? How can I have the instrumentation that's there always? And certainly I know within our own company, we've been doing, this work, this assessment work for many, 20, 30 years. But we've also recognized that we've got to be, to your point around the one person does this, one person does that. How can we be a total solution provider on that idea of sustainability and reducing and making systems more efficient? So our company has a company called EcoPlant, and EcoPlant has been a huge value for us, because they're able to place the instrumentation in place. And then the other piece of this, and Elvira, you know this because you're a modeler, you're simulator. It's about developing the algorithms that will give you actionable results. And so I think that's where the value is where are the algorithms, where is the knowledge that's going to take this information that we're getting, because we're not short on information. We get a lot of information. So how do we take that information, synthesize it, make it worthy of some action, and then we can take it from there. So it's certainly getting this information remotely is important. Getting this information in a way that is digestible and actionable. And that's kind of what our friends at EcoPlant does for us as well. So we're seeing more of that. Yeah.
Do you think when we see it more that, and then we have all this like algorithms can analyze, would we need compressed air auditors, or it will be changed by the Chat GPT of compressed air?
Yeah. I mean, look, everyone's asking, AI, it's a hot topic right now, right? Because of Chat GPT, and it is true. We have more power, especially the more data points we're able to get. Like certainly within my company, and when we look at maintenance agreements, right? How can we be better at keeping uptime as a priority? And how can we also prevent rolling more trucks, as we call it, right? So if you can solve a problem remotely versus having to send someone 200 miles into this, somewhere in a remote area, that's a huge value, right? So I think that's one thing that's happening is not only is it an efficiency play, but it's also a maintenance play within the world of AI. So I think there's probably everyone's working on that, and we have some aspect of that right already because of all the data we've been able to gather from compressors over the years remotely, and we're taking that data and looking at how does that impact the system. So I think that's in play right now. I don't think it's fully mature, and that's why it's a hot topic right now. Is how do we get that to a more mature level? We've been talking about predictive maintenance forever, though, as you know,
Yes,
right?
it's very trendy word, a very trendy
Friendly work.
combination of two words.
Yeah, exactly. But I think it is more than that, right? And I like to call it day one help. How do you maintain the health of that system the way it was day one when you installed it?
Yeah, I think it's also important, the training part and the awareness part for energy managers, maintenance managers, because sometimes you go on the plant and you talk about the AI, and it is some aluminum plant with a harsh environment, and there is the operator who uses the open pipe to remove fog. That was my recent visit on the plant. So that the compressor is used for everything. Of course, you cannot propose him to have a fancy dashboard because he works on the machine, and you cannot say it's inefficient use because he comes at 4 a.m. in the morning and he has to see his machine, so he has to remove the fog. So I think it's still a big gap in terms of the what we develop now. But I think this information and also the human factor and the learning we can take in the algorithms then to train actually them, and not to provide some fancy dashboard that no one will use then at the end. So we'll also have it seen it already. Chad, I think I have like last maybe question. What do you think most of the challenges in compressed air industry, like what you, I don't know, what your headaches that you experienced in the past years, and so what is as the compressor supplier for you is the main one of the main challenges?
That's a great question. I would say within our work around assessments and around improving the efficiency of systems, um, is most likely misbeliefs, if that makes sense to you. So maybe I should explain it, right? Is misbeliefs. We often struggle with plants having kind of a rush to judgment on what's causing the issue or why they're, often when we're called in, it's because there's a problem and there's any number of solutions that are in people's minds, and it just comes from not having the data, right? And so we say without data it's just guessing, and that's what we find often is but people hold very very strongly to their beliefs, right? Around the compressed air system and what's happening with it. Goodness, it is true, they've lived with it for all these years, they should know, but often it's measurement and data that answers the questions for us. And so I would say judgment without data is maybe one of our bigger challenges.
Okay, great. And I think you kind of we come back to the first question of the where the industry now, and you said that it's more on the monitoring, the continuous monitoring, also the decision based, like that data-based decision making,
Exactly. Yeah,
and as well as the thing that you work now in the ISO for the updating the 11011 to explain people that they have actually to monitor it all the time and then make decisions.
absolutely. Yes.
Sounds great. It's on a very good track. So, Chad, thank you so much. I wish you a lot of success also in the standardization and in all of your roles. I know there were like 6 or 7 that you mentioned before. I hope you don't forget to have a vacation, and I hope we can meet once again for another interview to talk maybe on something more specific.
Sounds good. I'd love to. Thank you.
Thank you so much. Thank you, Chad.
All right. Take care.